Today we're going to be talking about section 4.2, which is on graphing quadratic functions in vertex or intercept form. As you recall, yesterday we were graphing quadratic equations or quadratic functions in standard form. Well, the first form we're going to talk about today is vertex form, and it's y equals a times x minus h squared plus, in parentheses, plus k. Make sure that you get this equation on your note card. So the graph of y equals a times x minus h squared plus k is the graph of y equals a times x squared, translated horizontally h units and vertically k units. So once again, our vertex is hk, just like the absolute value functions we graphed a couple weeks ago. The vertex is the ordered pair hk. The axis of symmetry, therefore, is the line x equals h. Once again, if a is positive, it opens up. If a is negative, it opens down. So what we're going to do is we're going to take what we now know and graph an equation if it is in this vertex form. So remember, we are looking for the vertex, which is the ordered pair x, y, obviously, but in this case, in our equation, it's hk. So we're looking here, and the vertex is going to be 3, negative 5. Now notice we have x minus 3, but up in the equation above here, we also have x minus h. So the h is really 3, and then the k is minus 5. So here is our vertex. So the vertex is 3, negative 5. And obviously our axis of symmetry has to go through there. So that's the line x equals 3. And then we're going to find a couple points on each side. Well, we have the vertex at 3, negative 5. So let's put in, again, 4 and 5, 2 on the right, and 2 and 1, 2 on the left. So if we put in 4, 4 minus 3 is 1. 1 squared is 1. 1 times a half is a half minus 5. So that's negative 4.5. And if we put in 5, that's going to give us negative 3. Two is going to give us negative 4.5. If we put in 1, that's also going to give us negative 3. And there's your graph. The vertex is 3, negative 5. The axis of symmetry is x equals 3. Example 2 says we're going to use a quadratic model in vertex form. So again, we look at this equation. Y equals 1 over 7,000 times x minus 1,400 in parentheses squared plus 27. So if we're looking at page 246, which is where the picture of the towers are at, here's essentially what we have. They tell us that the towers are 307 feet high, and that this distance, d, is the distance between the towers. So our goal is to find the distance between the two towers for A, and then for B, what are the minimum and maximum distances between the suspension cables and the roadway. So if here is the road, how high do the cables get from the road? So by looking at this problem, we do know what the vertex is. It is 1,427. So that is this point right here? Well, if we know that the vertex is 1400, comma 27, the x value is 1400, the y value is 27. So how far is it between these two towers? D. What are we looking for? Well, we know if it's 1400 from here to here, it also has to be 1400 from here to here. So that makes the towers 2800 feet apart. So the distance between the towers is 2800 feet. And B now says, what are the minimum and maximum distances between the suspension cables and the roadway? Well, again, we know that the minimum value has to occur at the y coordinate of the vertex. So the cables will be a minimum of 27 feet from the roadway. And a maximum of 307 feet. Because the towers are only 307 feet tall. So the cable is not going to go up higher than the towers. So the maximum distance from the roadway is going to be 307 feet. So right now, let's go ahead and graph a couple of these problems. Let's take, and why don't we do numbers 1 and 2. So go ahead and pause the video. When you are ready, you can hit play. So here's a graphs of those two questions. Number 1 has a vertex of -2, -3. The second one has a vertex of 1, 5. And then notice we also labeled the axis of symmetry on there as well. X equals -2 in the first one, x equals 1 in the second. The next equation that you should have on your note card is this one. It is the graph of an equation in intercept form. Y equals a times x minus p times x minus q. In this case, the x-intercepts are p and q. That will tell you where the graph crosses your x-axis. The axis of symmetry is halfway between your two intercepts, which would be p0 and q0, and has an equation of this, which essentially that is simply finding the average of your x-intercepts, halfway between them. So again, if x is positive, it opens up. If x is negative, it opens down. So in this case, let's graph example 3. Now, it doesn't look like it's in intercept form, so let's write it that way. This is really a -1, and then instead of x, I can write x minus 0 and x minus 4. So this will make it look like it's in intercept form. So in this case, the x-intercepts are 0 and 4. So if I do that, put those on here. So this is the ordered pair 4, 0. This is the ordered pair 0, 0. Now I know that the x, or the axis of symmetry, must be between these two, right in between. Well, I can take these two intercepts, 0 plus 4 over 2, which gives me 2 over 2, which is 1. So my axis of symmetry is 2. 4 divided by 2 is 2, which should make sense because if you look at your graph, we know it has to be halfway in the middle. So if you get your x-intercepts on your graph, you can just find the middle point, or you can use this formula to plug it in to find out what that axis of symmetry is. So now, using the axis of symmetry, we have to find the vertex. So if we plug in the vertex, we know that it's going to be 2 something, because that's our axis of symmetry. So now you plug in 2. Well, that's going to give us negative 2 times, if we put in 2 there, that's going to give us negative 2. So that's going to give us 4. So the vertex is going to be at 2, 4. And then we draw our graph. The nice thing about intercept form is once you have the intercepts, you have to find one point only, that's your vertex, and then you can go from there. So again, notice in this case, we're going to label the x-intercepts, our vertex, and our axis of symmetry. Now in example 4, we're going to use a quadratic function in intercept form. It says if an object is propelled straight upward from Earth with an initial velocity of 80 feet per second, its height after t seconds is given by the function h of t equals negative 16t times t minus 5, where t is the time in seconds after the object is propelled and h is the object's height in feet. So how many seconds after it is propelled will the object hit the ground? So all forms that we talk about, when we talk about thrown objects, it's going to be a quadratic. Well, if I throw something, it's going to follow this curve, this quadratic equation. The first time is a time when it leaves the ground. The last time is a time when it hits the ground. So what we're going to do is we're going to take this equation in intercept form. Now again, I'm going to rewrite this one so it looks like this. This is in intercept form. So in this case, we know that our intercepts are 0 and 5. Okay, so 0 and 5, those are the two intercepts. Well, if one intercept is at 0 here and the other intercept is at 5 here, how long was this thing in the air? So it was in the air for 5 seconds. So it will hit the ground in 5 seconds. Second, what is the maximum height of the object? Well, we know that the maximum height occurs right there. Okay, it's a vertex. So we have to now find the vertex. Well, we know that the vertex is going to occur halfway between here, which is at 2.5. So we plug those in. So we're going to get negative 16 times 2.5 times negative 2.5. And so now what we need to do is find out what that is, and it will give us our maximum value. So the maximum value of this is, if we multiply a negative 16 times 2.5 times negative 2.5, we get 100. So our vertex is really 2.5 comma 100, which means the object's maximum height will be 100, and I think we're in feet here. Yep, 100 feet. Okay, so the maximum height is 100 feet. And that will occur when it is 2.5 seconds into this flight. All right, so let's quickly graph question, let's go 6, and then let's do question 8 as well. So go ahead and hit pause on the video, and then hit play when you are finished. So graphing number 6 gives us intercepts of 4 and negative 1, which would make the axis of symmetry right in the middle at 1.5. Plug that in, we get a vertex or a y value of negative 12.5. So the vertex is 1.5, negative 12.5. The axis of symmetry is x equals 1. And we have our intercepts at 4, 0, and negative 1, 0. In number 8, you throw these intercepts in here, and you find that the intercepts are 0 and 50. Half of that is 25. So the vertex is 25, and you plug that back in, and you get 15.625. So that means the football will reach a height of 15.625 yards. All right, the next thing we're going to talk quickly about is the FOIL method. This is a quick review. Remember, FOIL means first, outside, inside, and last. So when we do the first, that's x times x, which is x squared. We're going to go the outsides, which is 7x. The insides, which is 4x. And the lasts, which is 28. So then if we add our like terms up, we're going to end up with x squared plus 11x plus 28. Now the reason we do this is because we're going to look at changing from intercept form, which is here, into standard form, which if we recall, standard form is y equals ax squared plus bx plus c. So we simply have to FOIL this. Now if you look at this, because multiplication is commutative, I would recommend that you FOIL them first and then multiply by 3 when you're done. You don't have to, but it'll make your number smaller. So if we FOIL this one, we're going to get x squared plus 6x minus 4x minus 24. We put our like terms together. We get x squared plus 2x minus 24. And so now, if we distribute the 3, we're going to get 3x squared plus 6x minus 72. And so here is our equation now in standard form, and here is our equation in intercept form. So that's how we go from intercept form to standard form. Well, the same thing is true for vertex form to standard form. We want to make sure that we still do the same thing. We're going to FOIL this one as well, but it's going to look a little bit different. So remember, this squared means that you have 2 of them. So if it helps you, rewrite it like this, because that's really what it means. You have 2 of them. So f of x is going to equal, and again, I'm going to do the FOILing first, x squared plus 8x plus 8x plus 64. So now we add our like terms up. So we have x squared plus 16x plus 64. And then do the distributive properties. So we're going to have 1/2 x squared plus 8x plus 32. And then now we can add that 35 on the end once we've got rid of everything else. So our function is 1/2 x squared plus 8x plus 67. And now here is our equation in standard form, and we brought that from an equation in vertex form. So let's look at a couple examples of how to do those. Sorry, I had some technical difficulties there. So let's look at a couple examples of how to do these. Now there's lots of them in here. Let's go ahead and we'll do one of each. So let's go with question number 11 and that one's from intercept form. And then let's do number 14. Okay, so let's do those 2 problems. Go ahead and pause the video and you can hit play when you are ready. Here are the answers to number 11 and number 14. So today we talked about a couple of things. First, we want to be able to graph equations in vertex form. Make sure you can graph equations in intercept form, and make sure that you have both of those forms on your note card so that you can use them if you forget how. And then we recapped a little bit on foiling and how to change from either intercept form or vertex form into standard form. So here is your assignment for section 4.2.